Cool. Okay. Thanks for everyone for coming. I think we're gonna go ahead and get started. It's right at 11:02 on my time, so that hopefully more people will show up. But for everyone who's here, I want to make the best use of all of your time. Okay, great. So for those of you who aren't really sure what dual funding is, maybe you've heard people say that word before. Let me give you a kind of a quick overview, I guess, of how opening a channel on Lightning works right now. Then we can talk really quickly about what dual funding changes. And then I'll go ahead and get into the demo. Okay, so how does channel opening work on Lightning right now? So right now on Lightning, so when you open a channel, this requires sending some messages, a series of messages between two nodes. So let's say we have like node, oops, keep hitting the wrong button there, node A, and I'll go up to, so we have like node A, and it's talking to node B. Right now, just because of the way that the protocol is, written, when you open a channel, channel A decides that they want to open a channel to, or node A decides they want to open a channel to node B. And when they do that, they, they will usually start this in C Lightning. They'll do something we call like a fun channel request. And it'll say, so node A will call like Lightning CLI, they'll say fun channel. They'll give you node B's pub key ID, which is like the identifier. And then they'll say how much money that they want to put in it in the channel. And this is the command that you would run. And then, so what's going to happen behind the scenes is node A, it's going to send a message to node B that is, hey, I want to open a channel to you. So they'll send an open channel message. Node B will decide, oh, that looks like a great opportunity for you to open a channel. I don't have any problem with that. So they'll send back something. They'll send back something to node A called accept channel. Oops. Sorry. It's harder than I thought. So node B will send that back. Node B sends back accept channel. Then I forget exactly how this is because I haven't done it in a while. So node A will then be like, okay, great. With this info, this allows node A. So open channel and accept channel contain a lot of information. Once these have been exchanged, node A has enough information to know what the funding output script is. What is this exactly? I guess this is more of a how our channels opened in Lightning talk than how does it work exactly. But the funding output script is what you need. This is what, so node A is going to make a funding transaction that has, and this is basically this is a transaction with an output that pays to a 2 of 2 script. So that's what node A needs to produce. In order to know the 2 of 2 script, they need to know node B's like funding pub key is what we call it. And that comes back in accept channel. So this includes some stuff, a bunch of channel parameter stuff from node B, but it also includes their funding pub key. And node A sends their funding pub key to node B and open channel. Like I said, there's a lot of other stuff in these messages. These are kind of just little packets of information that get sent between nodes. Anyways, but after they've been exchanged, node A can go ahead and create the funding transaction. So they make a funding transaction on their own. They have their own, node A has their own inputs and outputs, one of which is the funding transaction output, which includes the funding output, which will create the channel. This funding output, once it gets mined, will create the channel. So the channel opening is basically when this funding output gets included into a block and is an output that then can be spent. Okay, so once you have this funding output created, You need the funding output and the funding transaction ID, really. So you really need the funding transaction ID, which you get from Node A knows, because Node A builds the funding transaction, right? So Node A builds the funding transaction, which means that Node A knows the funding transaction ID, and outnum, this is like really detailed, but that's fine, and outnum of the funding output. Then since Node A knows these things, Node A can now can build something called a commitment transaction, which spends the funding output. Okay, cool. I should probably look at the spec to make sure I'm getting this exactly right. But basically, once Node A can build a commitment transaction and knows the funding ID, it can build a funding commitment transaction, and then once it knows the commitment transaction, it can, since it knows the commitment transaction, it is able to create a commitment transaction signature. And that is what it sends to Node B. So it sends to Node B two things. It sends them the commitment transaction signature, and it sends them the funding transaction ID and out number. Basically, this will let you, these things together will let you identify the funding output when it gets published to the block. Right, so you notice it's built the funding transaction, but it hasn't broadcast it yet. So then I should probably double check. At some point after that, then Node B will send to Node A, so they'll get back. This will come back. It'll send its commitment transaction signatures. At some point, it'll send those back. Those come from Node B, get sent back. Oops. And then once Node A has this commitment transaction signature, it checks that it actually fits the commitment transaction. So Node A will then validate the transaction signature, the commitment transaction signature that it got. And then once Node A has a valid commitment transaction signature, basically what this means is this guarantees that Node A can spend the funding output. So you wouldn't want to put money into a transaction and broadcast it. If you want to put money into a funding output, basically, right? Since that's 2 of 2, you don't want to broadcast that to chain until you have the guarantee that you can get your money out of that. The guarantee that lets you get your money out of it is this commitment transaction. Commitment transaction is basically all that this is a transaction that spends this funding output that you put in the funding transaction. So there's 2 transactions here. Sorry, 2 transactions. The funding transaction, which has a 2 of 2 output, and then a commitment transaction, which spends the 2 of 2 output. Right, so you don't want to publish the funding transaction here until you have received a signed commitment transaction, which guarantees you can close the channel. Okay, cool. So this is all what happens. This is like all, so why am I going into so much detail about this? This is the entire, this is what happens when you open a channel. This is basically the entire negotiation that needs to happen before the channel can be considered open. Once you have successfully have gotten a commitment transaction from your peer, Node A can go ahead and then broadcast the funding transaction. And then after that, you're kind of just waiting. Both nodes wait. Both nodes are waiting until they're waiting for the funding transaction to get mined, and then they're also waiting for that to until it reaches a depth of like X. And this depth was negotiated as part of the open channel message that you sent originally. Okay, cool. So that's basically how a channel opens right now. Once both sides watch, so both sides like A and B watch the blockchain for the funding transaction ID that node A sent. And then once they see them, so they'll like first they see it unconfirmed, and then they see it confirmed, and then they see it buried at X blocks. I think it defaults to like 6 or 3. I forget what the default is. Yeah, but you basically you want to make sure that that transaction is definitely in the block and there's no chance it can get reorged out. Right. Okay. So once it's buried, then just to finalize it, node A and B will tell each other, hey, they both send a new message to each other that's called funding locked. They send this gets sent as soon as this milestone is reached. You send a funding lock message to your peer. Once you've both exchanged, so that means I've sent and received a funding locked, which is confirmation that I've seen the funding transaction in my version of the blockchain reach whatever dots we've agreed on, let's say 3. So I'll send my funding locked when that happens. And then node B, like the other side, once they on their version of the blockchain, once they've seen the funding transaction buried at the same number of blocks, 3 blocks, they'll send a funding locked. And then once both of us have exchanged a funding locked, this marks the end of the open channel process. Super exciting. Okay, so open channel has ended. And then you move on to something that's called normal channel operations. All of this is outlined in the spec, so I'm gonna see if I've got it open. Do I have it open? Yes. So in the RFC, there's a 0.2 peer protocol. This view of it is in the draft that I have for dual funding open, so some of this won't look like the current thing, but what we've just talked through is this right here, this section. So we talked about open channel when A tells B they want to open a channel. Accept channel is when B says back to A, okay, that sounds great, here's some info you'll need. Node A will make the funding transaction and will send the funding transaction ID and their commitment SIGs over in this funding created. So this is sent from A to B, and then B sends back to A, okay, great, I've got your funding transaction ID, I've built the commitment transaction and checked your signatures, that looks good. So now I'm sending you my signature for the commitment transaction for this funding transaction you've created. So this B will send that back here, and then at the end, they'll do funding locked. Great, okay, so we've just learned how the original and current channel establishment protocol works. Once it's done, it goes down to this section. So this is what I mentioned, like once it's finished, you move to normal operation, and then you've got a whole different series of messages that happen. Okay, cool. So that's how it works right now. So what does dual funding change? Like, so what's moving? What are we moving? So this is what we're moving from. This is the original or the current operation. Dual funding changes the protocol a decent amount. And so the goal of dual funding is to allow node B to also contribute inputs to the funding transaction. Okay, cool. So you'll notice on the whole protocol that we just walked through, we just talked our way through, the only person that built the funding transaction, when did the funding transaction got made? It got made after node A received an accept channel. They went and just created whatever funding transaction that they wanted to, with the only requirement is that the funding transaction included this one output that had a 2 of 2 script. That's basically the channel script. So node A is allowed to create any transaction that it wants. That transaction, just the only requirement is that it includes an output to this 2 of 2 script. And that's basically the opening of the channel. The channel, that's basically represents the channel. And once I get to mine, then the channel's opened. Okay, so node A can do whatever they want. Cool. So what we want to be able to allow is we want to allow node B to coordinate with node A to create this funding transaction. So in order to do that, we change the protocol a good bit. So now instead, so the old way, node A would send the funding transaction ID and the funding output like index, which you need both of these, right, to identify an output to spend. You need the transaction ID and then which output it is on that transaction. So node A used to just create this funding transaction. They wouldn't broadcast it. This is important. You can't broadcast it to get a commitment transaction back. So they would just tell node B, hey, here's what the funding transaction ID is going to be, and this is what the output will be. And then node B would just say, okay, great. Here's some commitment transaction info you need so that you can spend it if you need to. Okay, so the new way is that instead of doing that, now we're going to collaboratively build a transaction together. So this means that we no longer need to send a transaction ID and funding output because instead, no more this. Now, yes, send every input and output to peer. Okay, so as you can see, it's gotten a little more complicated. There's more information we need to share between two peers, but the upside of this is that you get more interesting and complex transactions, and when your channel opens, it's more likely, or there's a possibility for opening channels where both sides have a balance at the beginning. Okay, so I don't know if I want to talk through how we accomplish this. Yeah, sure, whatever. Okay, so what changes? Open channel is basically the same. It's just been renamed to open channel 2. Very clever. So there's still a node that decides they want to open it. We call it the opener. So node A is now known as the opener, but I'll keep calling them node A because that's easy. So they still send like open channel over to the peer, and then you still get back something. Haha! Guess what you get back? You get an accept channel 2 back from node B. We'll send that back. Now node B, another name for node B is also known as we call them the acceptor, because they're the peer in the channel that's sending back the accept channel note, which makes sense. Okay, and so now instead of, so it used to be node A would build the funding transaction. Now instead they start sending over their inputs and outputs. And node B will either respond with their own input that they want to do. So this part of the protocol, I call this the interactive transaction construction part of the protocol. And so basically nodes will take turns answering messages back and forth from each other. Node A is the opener. They're responsible for always adding the output that is, so this one in this example would be the funding output. So this will be that 2 of 2 script, right? That opens the channel. And then, let's say if B is adding an input, let's say they're adding an input for like 0.05 BTC. They're adding an input also for 0.05 BTC. Then this is node A, this is node B. B is going to want to send back a change output probably, right? This is change output. And then node A is also probably going to want their change output. So this transaction will have like 3 outputs on it and 2 inputs. And then once a side is finished, they'll say something called add, or I think I might have redone these. I think these are actually, I'm sorry. Okay. So then you do tx complete. So this is basically signaling, hey, I'm done. So B's done adding things. Maybe A realizes they need to add another input that's got money for fees on it. So then B is going to keep responding, hey, I'm done. A decides they want to update their change output because they had to add more money for fees. So they're going to remove an input, remove change output. Oh no, that's it. Sorry, they're going to remove an output, and then they're going to re-add it. Sorry, I'm going into a lot of detail here, but hopefully this is interesting. So then they re-add their output. They put their change output back. So A's change output. A removes. A's money for fees. This was A's change output. This is B's. This was A added ending transaction. B added. A added. Okay, so they talk back and forth like, hey, here's all the stuff. You know, B's done, so they're just responding every time they say, hey, we're done. And then A is also done, so they'll do TXI complete. And then once you get 2 of these in a row, that's when this kind of transaction construction part of the protocol is considered ended. So end that section. So now we move on to the next part of the, next part of the funding transaction stuff, which, if you recall from the first version of things, was just exchanging commitment transactions, right? So both sides should now be able to build the funding transaction. So they should be able to figure out what the, so node A is going to build the transaction that was communicated via the above. So they're gonna build a transaction that was communicated. They're gonna figure out what the TXID and output are for the funding output, right? They're gonna build a commitment transaction for that output that spends that output, and then they're going to send node B their commitment transaction signatures. Okay, so the next thing that node A will send to node B is going to send a commitment transaction, commitment signatures. I forget what this is called. But they basically send their commitment transaction signatures to B, and then B should be able to reply with their commitment signatures. Of course, B checks to make sure that A has given them the right thing, and then they send node A their commitment signatures. So now we've got kind of a little bit of a departure. Once you've both got the commitment signatures that you need, yeah, once node A had sent the commitment signatures, then they'd send their transaction signatures. A will send the transaction signatures. These are the SIGs for the funding transaction. So these were the SIGs for the commitment transaction. Cool. And then node B will respond back with this A, also with theirs. Once those have been exchanged, then you can then you broadcast the funding transaction, and then then you basically are back to the same place you were with the back to the back to kind of the original like opening thing where you're waiting for the funding transaction to get mined, and then once it's been buried, let's say 3 blocks, then you both exchange node A or B, or whoever sees it first will send the funding locked. And so that's kind of like we're waiting just to exchange that, and then once that's done, we're done. We move over to normal channel operations. Let me check really fast to make sure I got the names of these, right? TX complete, TX signatures. So that TX signatures message is actually considered part of the interactive transaction construction, though as you'll notice, there's kind of the negotiation section, and then we do some other stuff, and then we go back and send the transaction signatures. That's because funding transactions are really special. You want to make sure that you definitely have signatures for the commitment transaction before you broadcast or make the funding transaction broadcastable. So it's a little divorced out, and then it's commitment signed is what it's called. Okay, and then this is, yeah, transaction signatures is the same as this one. Okay, cool. So that's basically, so this message here is, oh, I know sorry. Sorry, I just wanted to. Whatever. Okay, these are the same. Okay, cool. So that's basically overview what happens. Okay, great. So let's make this happen. Okay. Cool. So the latest version of Sea Lightning, the one that we'll be shipping this whatever, this is all implemented, which is very exciting. Make sure it's made. I just tested this, so hopefully everything's fine. Okay, great. Okay, so for this example, basically all I'm going to do is I'm going to open a channel, and both channels are going to put money into the opening funding transaction, which will be very exciting. Basically, I got to do a couple things in order to put Sea Lightning into the, what do you call it, the mode where it can use dual funding as a protocol, so the secondary protocol. When you start the node, so normally when you start Lightning D, you do stuff like daemon, you pass in config options. One of the config options, so you need to pass a config option to tell your Lightning D to enable this protocol. Since it's experimental, we put it behind a flag. It's called experimental dual fund. Okay, so I'm not going to do that. I'm actually going to use this kind of nice script that I like a lot that lets me run local reg test connected nodes, so I can like test stuff out on the command line pretty quickly. I find it's really helpful for like prototyping stuff, or if like I need to write a test, but I'm not really sure exactly what to test. I can run through a couple things locally. So that's in contrib startup. Reg test. It's this guy. It's a nice little script. There's one thing to note about this script is that it's kind of hard. There's not an easy way right now to add additional configuration options to the nodes that it starts. So I've like hard coded this thing in. I might try and see if I can get this in for this release, or I'll put up a patch. So if you want to play with it and it's easy, it'll be here. But basically, so I'm gonna source it. So this will add it to my command line stuff. It's got a couple aliases, so you need to make sure you source the script into your bash environment so you get all the fancy stuff. So start, I think it's start ln, I always forget. Start, yeah. So I'm gonna start up, let's start up 3 nodes, sure. Okay, so it gives me 3 nodes, like these are how I can kind of access them. And then it also gives me like a local Bitcoin reg testing. So to start, I'm going to need to send L1 some funds. So if I list funds, it should be empty. Okay, good. So in order to like do, what do you call it? In order to do dual funding, you have to have funds to put into a channel. So I'm going to need to add funds to both L1 and L2. These are like L1. So in order to do that, we need to get a new address. And then I need BTCLI to send address. Let's send it a Bitcoin. So I'm going to do the same thing with L2 now. So this is an L2 address because I typed in L2. And then BTCLI is basically a local reg test Bitcoin thing. Yeah, I'll send them a Bitcoin. So everybody has a Bitcoin. I need to mine it into a block. I did this earlier, so I'm going to cheat and you generate. No, that's not working. Okay, fine. I'm really weird about this. I really don't like generating blocks to Lightning nodes because they have Coinbases. So you can't, any money you use generate CLI to send to a Lightning node, you can't use for 100 blocks. And that just like kind of annoys me. So when I generate to stuff, I always generate to a address on the Bitcoin wallet. I don't know. You don't have to do this, whatever. Get new address. So I do generate address. We just have to do one. Okay, so now there should be money in the thing. Great. And then, so both of these guys have money. Cool. Okay. And it's all confirmed. So the guys both have a Bitcoin that we just sent them. That's awesome. Cool. Looks good. Okay. So now we want to open a channel. Oh, wait, there's one more thing we have to do. If I try to open a channel right now, even though both of these are running the dual funded protocol, well, I guess I'll show you what happens. It's the second node is not going to contribute funds. And the reason for that is that you need to add an additional plugin to your node so that it adds money to any inbound requests. Right now, it just like it treats any normal, right now it treats any inbound request as like a normal inbound request and doesn't put funds into it. I'm in the process of writing a quick little plugin that you can turn on and set some parameters as to when you want to add money to a node and at like what rate. So that's kind of like work in progress, but for now I have some test code that will do exactly the same thing for this demo. So I'm going to add, so if you're not familiar with C Lightning plugin architecture, there's some really great info in docs plugin. Basically, this is a whole way of adding extra functionality to C Lightning. So part of the dual funding flow in C Lightning uses, for the acceptor side of it, has a whole kind of like workflow that it goes through on the opposite side of those like signing things and whatnot, that allows your, whatever you call it, sorry, that allows your acceptor node to respond to these open channel requests, basically based on the policy that you've set up. So I'm going to be using the very hacky, I don't know if it's that hacky, I mean, it's fine, something called DF acceptor. Basically, this implements all of the hooks that you need when a open channel request comes in, and does cleanup and stuff if it disappears and whatnot. Okay, cool. So, okay, so what I need to do in order to make this work is I need to add it to the node that's going to be the acceptor, and that's going to be L2. So I'm going to just say plugin start. This is in test plugins. No. L2 CLI plugin start. Test plugins DF acceptor. Okay. Cool. And so you see it lists all the plugins that are currently active. So it's on. Okay, cool. So that's all the setup. All that we've done so far is we've put money into we created 2 new nodes, Lightning nodes. We've added money to their wallets, and then we've turned on a plugin for one of them, the DF acceptor one. Okay, so now we're gonna open a channel. Woohoo, it's so exciting. Except first I have to connect. So I need to get info out of this guy. Oh, okay, so now you can see the whole thing. Connect to that guy at localhost 7272. That's right, that looks right. Okay, so now they're connected. So first step to opening channel is connecting. Okay, so now This should just work, hopefully. I'm going to put in 0.08 because that's the, what do you call it? The way that so I know that the acceptor plugin is hardwired to match whatever you can up to the limit. Actually, here, I'll do this, might be more fun. So the current max channel capacity, if you haven't enabled Wumbo, which lets you do bigger channels, is 0.16 Bitcoin. So this would be like the max. If I, as the funder, attempt to put in the max, I know the acceptor won't add any because there won't be an extra space for them to add any money to the channel. It'll be at the max capacity already. So I'm going to put it down a little bit so we give our peers an opportunity to put money in if they want to. And then just because this is on RegTest, I usually put in like a very, very low fee rate. Don't do this. Okay, this is work. No. Oh no. Yeah. No, it's dying. Why is it dying? Method, open channel connect. Oh, this is embarrassing. Hang on, I can't read this. You gave bad parameters. It's too large. Oh, okay, never mind. It's not as smart as I thought. Okay. Just kidding. So someone needs to fix that plugin, basically. Is this gonna work? Aha! No! I gotta connect. Okay, sorry. This is what you get for deviating from your practice script. Okay, it worked. The reason it wasn't working was exactly the reason that what I said that the plugin could do, but clearly it can't. It tried to match the 0.1 that I added up here, and it was like, so it's trying to put 0.2 in, and the whole thing was falling apart because they're like, you can't create a channel that big, it's over the limit. Okay, so I put it back down to half the channel capacity, and so the peer matched my channel capacity, which is why it looks good. Yeah, so when I see list peers, so you'll see that it's awaiting lock-in. That means that we're still waiting for the channel to, we've produced the funding transaction, we've exchanged commitment transaction signatures, or at the point now we're waiting for it to be broadcast and then mined. So we're waiting for the lock-in. So basically your node is waiting until the blockchain includes the funding transaction and it's been confirmed up to like however many times, 3 times or whatever. Okay, cool, but check this out. This funding allocation IMSAT, it has got 0.08 Bitcoin for each side. So this means that we were successful. The other side of it actually contributed funds to it, which is super exciting. Notice how big this like transaction is. This is gonna be nasty. Hang on. Okay, so we can like use BTCLI to decode transaction, which is cool. So we can see that it's got 2 transaction inputs. One of them is ours ostensibly, the other one is from the peers. So one of these L1s, like the first nodes, and one of those is node B's. They've managed to successfully exchange their signatures with each other. And they've produced a transaction that's got, like we said, 3 outputs. This is the funding transaction output. No, this is the funding output. I'm sorry. This output creates the channel. You notice that it's got a longer address than these guys, or rather that the type is a script hash. That's because channels elected to have 2 multi-sigs. So yeah, so this is our funding output that creates the channel. And then these are the change outputs for each of these. This is kind of cool. You'll notice that both of them, so both of our nodes started with 1 Bitcoin each, right? They put out 0.8 to here, so you can neatly see that like 0.8 is missing, but then there's also some amount of money that's been paid for fees. One of these nodes has been paid more for fees than the other. I can tell that this one is so this one would be the acceptor's output, change output. I know that because they paid less in fees than the opener. The opener, so like who pays fees on this opening transaction, right? Okay, so right now as you can imagine, when you open a transaction, the person who opens it pays for the funding transaction. which is the only thing that makes sense because they're the ones who build it, right? So they build it, they pay for it, they broadcast it. It's all their deal. Now, since we do it together, each peer pays for the inputs and outputs that they put into the transaction. So the acceptor side of it paid for this output, and for whichever output that they, whichever other of these inputs, they paid for one input and one output. The person that opened the channel pays for one input, one output. They also pay for the funding output. So the opener paid for this output in particular. So that's why their funds are like, their fee is a little more than the other person. Okay, cool. Yeah, and then I guess we can mine a block. Let's mine like what, like 3 blocks? And then oh yeah, okay, so that mining it moved it from awaiting lock-in, so it's now in channel D normal, which means this channel is now open and ready to be used. Cool, yeah, state is it normal. So mining the transaction, or basically broadcasting 3 blocks, move the chain forward far enough so that the funding locked messages would get exchanged, and now you're basically back to where you would with any other normal channel. Okay, I've done a lot of talking. Are there any questions that anyone wants to ask about any of this? Someone's typing. Cool. So MG asked, are there any backup channel security differences with a funded channel versus a normal channel? The answer is no. The channel is exactly the same. So the backup, so like backups in Lightning, what data needs to be backed up in Lightning, I think is kind of the real question that you're asking, right? Is any of that data related to the open channel process? The answer is the data that you need to keep track of are the commitment transactions. And the commitment transactions have not been changed at all for the opening by changing the opening protocol. In fact, the commitment transaction is exactly the same no matter which of these protocols you use to open a channel with. So your data backup requirements are unchanged and in fact are identical because you still need the commitment transaction data. Looks like someone else is typing a question. No, just the things. Okay. Let's see what else. What else can I tell you about? Yeah, what else would be interesting to know? Splicing. Oh, that's a great question. Okay, so Adam wants to know about splicing. So the cool thing about this open transaction thing is this. So if we go back up to this long thing, this interactive transaction construction. Basically, you can reuse this for building so now that we have a protocol for building a transaction between 2 nodes, you can use this. There's 2 places that we want to use it. The next place that we want to use it is for closing a transaction. So this would basically mean, so what would that mean? Right now, when you close a channel. Close a channel. Another way of explaining what happens when you close a channel is you spend the funding output, right, that was created in the funding transaction. So it would be cool if so right now the transaction that you use to spend the funding output is canned. Sorry, this isn't splicing, but we'll get there, I promise. Okay, so right now when you spend the funding transaction, you use like a close command on C Lightning. And this is I'm gonna call it a canned transaction format. So there you can't really change what goes into that transaction. But we can take the interactive transaction protocol, and we can update the closing channel. Update the closing channel protocol to use this, to take advantage of this. So instead of having a canned transaction format, you would have a closing transaction could be anything, even another funding transaction, which basically gets you splicing, right? That is basically splicing. There's a little more nuance around splicing. There's a little bit more nuance around the splicing question, and that basically, like, so this is definitely like kind of what you want to happen for a splice, right? You're going to spend the previous funding transaction, and you're going to spend not funding transaction, you're going to spend the previous funding output in a transaction, and that transaction is also going to create a new output that it's going to create a new output that allows the channel to continue. So there's like basically the only question then is for this whole process is, are you still allowing like payments to move through the channel while you're waiting for this closing funding transaction hybrid that you've built to get mined and buried, right? So that's like 30 to 60 minutes or whatever. Maybe it takes longer. So are you still allowing payments to move through the channel is kind of the big question around like how splicing works exactly. This is possible. It's possible, but it might require a little bit of probably going to result in more commitment transactions. So basically, one way that you could do this, again, we haven't exactly figured out what the protocol is exactly. Christian Decker has some good ideas, has had some really good ideas on the mailing list in the past about how this would work. The commitment transaction, so basically you would need for every splicing command. So for every splice that's currently in flight and hasn't been locked in yet, right? So this kind of goes back to when you're opening a channel, you have to wait till lock-in happens before you start sending funds through it. So until lock-in happens, you'd basically need two copies of commitment transactions. Two commitment transactions for every in-flight splice. One of these is for the old funding output, and one would be for the one for the new not yet confirmed buried output. Yeah. So basically, you would need your commitment transaction. Whenever you exchange commitment transactions, you would need to change the message format so you could send more than one commitment transaction. So there's like a little bit more paperwork involved, so to speak, with splicing, but I think that encompasses much of it. So yeah, this is like a very big step this is like a huge step towards splicing, right? Because we're basically halfway there, or like kind of over halfway there. Cool. I've got about 10 more minutes. If there's any more questions, be happy to answer. What is up with podals? That is a great question. I actually have so we've decided to punt on podals. Punting on podals. The reason is that Lord Lloyd Fournier wrote a really great post to the mailing list that basically gave a good explanation of why the exposure of your, so what is a podal for those of you who aren't familiar? A podal is basically a proof of discrete log equivalence. Basically, this is a way of making a channel opener, prove that their UTXOs sent in TXAdd input are valid and exist and that they haven't, and that they haven't used them elsewhere, sort of. And you kind of like prove that you haven't used them elsewhere. The point is that you're trying to keep a node on the network from attempting to probe other. So POTLs are kind of a information leakage defense. The goal is to keep it, because like, so right now, since anyone can ask you to open a channel with them, you send them your UTXO set, or like a portion of your UTXO set. When you send them add TX add input. TX add input includes spendable UTXOs, and the fear is that this will allow people to track your UTXO set. Lord Fournier actually had like a really good response as to why this isn't something that you need to worry about so much. I need to go back and look at it. But the general idea is that your UTXOs are going to become public in short order anyway, if you're actually looking to spend them into channels. And by opening a channel, you're kind of sort of giving away who your UTXO set is anyway. I'm totally like messing up what the explanation was, but let me see. Oops. Pulling up the page. Yeah, so basically, based on what Lloyd kind of came up with back in January, here, I'll paste the link in the chat so you can look at it. It's generally decided that we could wait on POTLs until it either became a big problem, and then we have a solution that we could use. So POTLs are definitely something we can implement to attempt to drive down the number of these like probing attacks and their efficacy. But that it was like a lot to do for just starting out, so to speak. Is a done idea. So they haven't like gone anywhere. It's just been made not like a priority for like first getting the protocol out and ready. Yeah, great. Okay, I have about 5 more minutes. Oh, okay. Plans for doing something to construct more interesting commitment transactions? No, I don't think so. Not that I know of. I have not heard of any. Okay, so the question is, are there plans for doing something like interactive transaction construction to construct more interesting commitment transactions? As far as I know, the answer is no. I don't think you want. Okay, so the thing with commitment transactions is that they are a worst case scenario. They're a worst case scenario. You do not want to publish a commitment transaction to chain. They're expensive. There's a good chance that you will pay more fees than you wanted to on it. If there are any payments in flight at the time that it goes to chain, it's expensive to get them out because you have to pay on-chain fees for every HTLC. If the HTLC wasn't big enough to cover its, what do you call it? If it wasn't higher than dust limit or ever, you've like basically lost those funds. Like commitment transactions are very expensive, and like I said, they're a kind of like worst case scenario. You really only use a commitment transaction. A commitment transaction only hits the chain in the case that you and your peer are unable to agree on a mutual closing transaction, or your peers disappeared entirely. So like publishing commitment transaction is really, or you've got like like a payment you need to pull out and your peer is unresponsive. So I guess that's basically a subcategory of your peer is unresponsive. So making commitment transactions more complicated or more interesting or putting more different useful stuff in them is like not what you want to be doing at all. The closing transaction, the interactive closing transaction protocol that I was talking about is what you would want, really. So doing more interesting closing transactions, like I was saying, is kind of like a pre-step to the final splicing, like final form. That is actually kind of where you'd want to put that effort, and not into making commitment transactions any more complicated than they currently are. Cool. Okay, I have time for like one more question if anyone's got one. Okay. Daniel, did you have any last thoughts or anything?
All good on my side. I think Calais is typing a question.
Oh, okay. Oh, I think there's a recording, so maybe Daniel can post the recording link again just to round things off. Oh yeah, so I guess maybe just like going forward, like I said, the final this 10.0 or .10 release of Sea Lightning should be available end of this week or early next at the very latest. So it's currently in RC1. It's currently in RC1, so if you want to check out RC1 and give it a try, you can. The stuff that I showed with the little command line flag just got merged into master today, so you'd need to check out master if you wanted to look at that or whatever, or like to use that, because that's a great way to do it. Yeah, and if you've got any questions or comments, or you want to, I should post the link for the RFC thing in the chat also, so let me do that really fast. This is the wrong one. But if you want to take a look at the dual funding proposal, it is up and available on the internet at this link that I am in the process of posting. Cool. Okay. Okay, great. Cool. Thanks for everyone's time.